Good morning, student. Today we will discuss the magnification power by simple microscope and compound microscope. We all know the magnification is given by the angle subtended by an image upon the angle subtended by an object. Generally, it is tan beta upon tan alpha, but the angles are very small, therefore it will be beta upon alpha. And what is beta? Beta is the angle subtended by image upon the angle subtended by object. You see, the moon appears very big, but the size of moon is smaller than the size of stars. Then how it appears big? Because the angle subtended by moon on our eyes is very big as compared to the angle subtended by stars. We know, and the same formula for the magnification m equal to beta by alpha we will use for the microscope as well as for the telescope. Apart from that, magnification means what? In mirror case, magnification is given by minus v by u, or it is h dash by h. This is also the magnification power. And for the lenses we have magnification v by u, it is equal to h dash by h, or it is I upon O. The size of image upon the size of object. It is what? It is the size of image upon the size of an object. The size of an object. We will use these three formulas for the magnification by simple microscope and compound microscope. Let us see, before going to that, two more important points, that whenever we form the image, we will form the image at two conditions. Condition 1, when image formed at infinity. When image formed at infinity, and case 2 we will discuss, that is when image formed at least distance of distinct vision. Least distance of distinct vision, and that will be 25 centimeter. Least distance of distinct vision is 25 centimeter, and to get the image at infinity we must have to put the object at focus. Least distance of distinct vision, we can say it is near point also. The near point is 25 centimeter. Now let us consider the image formed by simple microscope, case 1, and for that we have to take, this is a convex lens. Here we have one convex lens, and the object is placed somewhere here, convex lens of certain focal length, an object is placed between F and O. O stands for the optical center. So we will keep the object here. This is O, and suppose the focal length is, this is the focal length F. An object is placed at this point. So this is F. So the first ray will come parallel to the principal axis and it will pass through the focus, second focus will be here. So this ray will pass through the, it will come this much inside. When we draw ray diagram, we must keep all these small things. So the ray will pass through the second focus, and when we extend this ray in back side, this side, so we will see it will go this way, and one more ray, it will pass through the optical center like this. Actually back side we are extending, the ray will go this side and it will extend this, it will reach here, and these two rays will form the image here at this point. So they will form the image here, and we can say that it is the larger image, and this distance, it is because the image is formed at least distance of distinct vision. A dash, B dash is the size of image, F is focal length, AB is an object, the ray, this ray is passing through the focus, this ray will go without deviation, this is another focus, F2 you can say. Now first case, when image formed at least distance of distinct vision. Case 1, when image formed at least distance of distinct vision. When image formed at least distance of distinct vision, V equal to minus D. This is minus V, and magnification formula we know. Magnification formula is, basic formula of magnification we know, M equal to minus V by U, and we will use that formula here. Distinct, DISTINCT, distinct vision. In previous, here also you can make distinct vision. Okay, now magnification is given by M equal to V by U, and U will be what? 1 upon V minus 1 upon U equal to 1 upon F. So from this equation we can calculate minus 1 upon U equal to 1 upon F minus 1 upon V multiplied with minus U equal to 1 upon V minus 1 upon F. Put the value, this is equation 1, this is equation 2. Put the value of 1 by U in equation 1. So M equal to, it will become M equal to V upon U. U is what? This 1 upon V minus 1 upon F. When we multiplied, it will become V by V minus V by F. This V cut, it will become 1 minus V by F. If V equal to minus D, so it will become 1 minus D by F. It will become 1 minus d by df, it is equal to, so the magnification will be m equal to 1 plus d by f. This is the formula when image formed at least distance of distinct vision. You should note down this formula, that magnification equal to m equal to 1 plus d by f. Then we have case 2. And what is case 2? For case 2, we should have to keep the object at least distance of distinct vision. Now what happened? If the object is placed at least distance of distinct vision, we can see that object clearly. Now we are keeping the object at least distance of distinct vision. Suppose if it is kept here, so this is our H and image will formed here. So we can say if the object is placed at least distance of distinct vision, this is theta 0, this is H and this is D. So it will become tan theta 0, it is equal to H by D, or if theta is 0 is very small, then we can write theta 0, it is equal to H by D. Say the equation is 1. This is the case when image formed at infinity. Case 2, when image formed at infinity. This we are discussing now. So this is theta 0. Now in this case, the ray diagram will see, ray diagram will be like this. The object is placed here, this is convex lens, and the principal axis, we have principal axis like this, which will pass through the O, and this is F. If we say the F is here, so an object is placed here, so this is the height of object. The ray will go parallel to the principal axis and it will pass through the focus. How much is focus? This much. So focus is this much, and the ray will pass through the focus little bit inside, and then it passes through the focus, and one more ray, it will pass through the optical center. See, both the rays will be parallel, they will not meet in any condition, either this side or even this side also they will not meet. We can make the diagram, so the parallel rays, so these two parallel rays will never meet and image will form at infinity. The arrow is must. Sometime the examiner cut half mark for the arrow. This is theta I. Now theta 0 we have calculated. Theta 0 is tan theta 0 H by D. This we have calculated. Magnification formula is given by, magnification formula is M equal to H dash by H, it is equal to V by U, equation 2. Now here this is theta I and this is F, and image is formed at infinity. So tan theta I will be H dash upon minus V, because what is H dash? H dash is size of image, size of image versus the size distance of image. Because this image will form somewhere here, so that distance will be minus V, because incident ray is going that side, and height is H dash we have considered. So from this equation, from equation 1, what will be the value of H dash? From 2, from 2. H dash equal to what? H dash is nothing but it will be V by U into H. This H dash we will put in this formula. Tan theta I. Later we will convert it to theta I. H dash V by U into H into 1 by minus V. This V we cut. So it will become H by minus U, equation number 3. Now as we have mentioned the U equal to infinity, U equal to at focus. So here this is U. So for this U we will write minus 1 upon, means F we will write. So tan theta I will be tan theta I will be H upon minus of minus F. This will be H upon F. Equation number we can give is at 4. And theta 0, already we have discussed that theta 0. So if the angle is small, we can write theta I H by F. Equation 5. Theta 0 H by D. So magnification M equal to theta I by theta O. Theta I is H by F divided by H by D. So it will become H by F into D by F, hence D by H, hence H is cut. The magnification will be D by F. This will be the magnification power in this case. So we have two cases. One is when image formed at least distance of distinct vision for the simple microscope, and when image formed at infinity. So we will have to keep these two formula. But generally what happened, this is for the simple microscope, and in simple microscope magnification is not much. It is only greater than 9. That means 9 times is larger. But 9 times larger is not that much. This is called simple magnifying lens. In watch shop you will get this. But to see the magnified power, or to see the magnifying image with of bacteria or biological cell, we need a compound microscope. And in compound microscope we will use two lenses. So first of all, what happened, the ray diagram in compound microscope, that we will see. Compound microscope, and with the help of compound microscope we can increase the magnifying power 1000 times larger than the object, because these are the very small cell size. So we can see that. What happened in this case, we use two lenses. One lens is called eyepiece. This is an eyepiece, and we have coaxially one more lens. It is both are the convex lens, not concave lens, convex lens. And we have one principal axis. The principal axis, common principal axis here. Although the name of the center we can give it is as C1, it is as C2. This line is common. This is this line which passes through the center, and this is called the principal axis. Both the lenses are fixed in a tube, and rack and pinion arrangement is there. And this is called the objective lens. So its focal length is f0. What it is called? The objective lens. And one more lens, it is called the eyepiece. Its focal length is f0. So both the side we will get f0, and this lens is both the side we will get f0. This is called eyepiece, and its focal length will be, suppose, fe. For this lens we have mentioned only f0. For this length, this fe is the focal length of this lens. And We all know the least distance of distinct vision is the distance of 25 centimeter. Now first of all, we'll keep the object beyond focus. Listen carefully, this is very important point. We have to keep the object beyond focus, but very close to focus, not far away. So the first ray will go parallel to the principal axis and it will pass through the focus and it will form the image here. Where somewhere here it will form the image, because one more ray, it will pass from the optical center, so the real rays, and we have to adjust such that this image is formed between C2 and F. This is A dash, B dash, this is AB, and this is the A dash, B dash. A dash, B dash is the image formed by for an object AB, inverted image, and this image is formed between C2 and FE. A dash, you can note somewhere, A dash, B dash is formed between C2 and FE. So again, the ray will come here parallel to the principal axis. We can measure, this is the focal length, it is near about, focal length is 4.5 centimeters. So this side also 4.5 centimeters. This will be the focal length. Now first ray will go parallel to the principal axis and it will pass through the focus somewhere here, and one more ray, it will pass through the O. So when we extend this ray, this side, this ray, and one more ray is here which will pass through the optical center, these two rays will meet at this point. So this ray will go here, but it will not. So these two rays will form the image here, and that will be the final image at least distance of distinct vision, and we can provide the name as B double dash upon A double dash. It is the final image. So to calculate the magnification at least distance of distinct vision, so at least distance of distinct vision, at least distance of distinct vision, here we have, because the image is formed at least distance of distinct vision, this, so we will have this distance as least distance of distinct vision. This distance will be the least distance of distinct vision, and we can say this distance is D. So the magnification M is given by, magnification is what? Magnification is given by M equal to beta upon alpha. But where is the beta? Beta is the angle subtended by image. So this is beta. We can say that this is beta, and tan beta equal to, actually beta is A double dash angle A double dash C2 B double dash is beta. And to get the magnification, we will consider that object is placed at least distance of distinct vision. So we will keep object here. If the object is placed at that place, least distance of distinct vision, so how much angle it will form? It will form alpha. So if the object is placed here, H, object is placed here, so this angle will be the angle subtended by object alpha, and tan alpha, we can say the tan alpha, alpha is equal to, here you can provide name A1, A1 C2 A1 C2 B double dash is alpha. Now to calculate the magnification power, how to calculate the magnification? Then tan beta upon tan alpha. So we will write tan beta upon tan alpha 10 beta upon 10 alpha. It will become beta is what? A double dash b double dash upon 10 beta a double dash b double dash a double dash b double dash upon c2 b dash upon c2 b double dash, and 10 alpha is again a dash b a1 b double dash upon c2 b a1 b double dash upon c2 b double dash. C2 b double dash is common. C2 b double dash is common, so we will write that, and then cut, because in denominator this will cut. See this way, this is the diagram. This diagram we will keep here. Now this will cut, c2 b double dash will cut. It will become a double dash b double dash upon a1 b double dash. So beta upon alpha, so we will write beta upon alpha, and then a double dash b double dash a1 b double dash into a dash b dash upon ab, a dash b dash multiplied करना ऊपर नीचे उससे. It will become a double dash b double dash upon a dash b dash into, it will be a dash b dash upon a1 b double dash, and this is nothing but a double dash b double dash. अब see here, you can see a double dash b double dash. For that, ab is an object, so it is one magnification power. It is the magnification power me, and a1b, it is a dash b dash. A dash b dash is the image for this object. For this object, image is this, so it will be mo, because for this object, this lens, object and image, so this will be mo, which will consist ab upon this. Since ab is equal to a1 b double dash, so we can put this a1 b double dash with we can replace this a1 b double dash with ab. So in next step, first of all, you can replace here only a double dash b double dash upon a dash b dash into a dash b dash upon ab. This is mo and this is me, so mo into m0. This is magnification. And remember this multiplication. Suppose one lens produces 20 times and another provides 20 times, so 20 into 20 400 times multiplication. So magnification will be multiplied. If it is 100 times, it is 100 times, so it will be 10,000 times. And when image format least distance of distinct me is what? 1 plus d by fe. Just now we have calculated. And what is m0? We will write m0, and m0 will be actually, m0 is this is m0, a dash b dash upon ab, so it will be m0 will be 1 plus d by fe. So a dash b dash, it will be v by v0 by minus u0, because this is the magnification h dash by h, it is equal to v0 by u0. So it is h dash for the first lens, it is h. This will be the magnification power. So 1 plus d by fe, it is equal to mod of v0 by u0. Magnification power when image formed at least distance of distinct vision. Similarly, you can extend it for the image formed at infinity.